So today we're doing the last thing, which is bed mass. So you've learned all the different operations that you need to do with rationals, fractions, multiplying, adding, subtracting, dividing, right? We're just putting it all together with multiple operations in one expression, right? So just as with integers, just as with exponents, the rules are the same. The B stands for brackets, and that is the first thing we look for, right? And that's the first thing we're going to do in the expression, right? So when we do work with brackets, especially with questions like these, they start getting complicated, right? So the tip is to work from the inside outwards. Like, so with a question like this, we're going to work with this bracket and work inside this one, and we're going to ignore everything else until we got this down to one number or down to one fraction. All right? And then we go left to right in there just for making it reading purposes. All right? I won't be putting too many exponents in here, but if there are exponents, that is the next thing that you should be aiming for. Right? Then reminder that D is division and M is multiplication. And these are tied steps. Right? Division doesn't necessarily come before multiplication or the other way around. The way we do these ones is we read left to right. Right? Read left to right. Do the one that shows up first. And same thing for addition and subtraction. You guys remember that from last time, right? Last unit? These are tied. So read from left to right. Left to right, just as you do with a book, right? So let's do, I'm going to skip the first one because there's no real BEDMAS stuff going on here, just a lot of extra negatives. Let's start off with this one here, okay? Now, we have brackets upon brackets here, right? And so it's sort of like you need to see through all these lower brackets and look at the overall picture. So these little round brackets on this particular question are just around a single fraction. So they're not isolating any math operations. They're just there to help identify the fractions. So we can sort of ignore these for now and notice that there's a big square brackets here. And that is the first thing we are going to do, is focus on these big square brackets and everything that's in here, right? So put my hand over here, so we ignore this. And inside of here, we have all of this. And we look at the math operations here. We have a subtraction and we have a division. What do we do first if we're just looking inside the bracket? Out of those two things, what's the first thing we do? Division. Yeah, we do division, right? And so just as before, but things become a little bit more complicated. So what is the rule for when we're dividing fractions? How do we divide fractions? Right? Michaela?
We need the same denominator.
No, that's for adding and subtracting. Dear Patel?
Just flip the second fraction.
Yeah, we flip the second fraction. Right? So this stays the same. We turn the division into a multiplication, and we flip that second fraction. And I'm going to keep the negative on the top. Right? So I'm going to work my way down here. So I'm just right underneath here, I'm going to write down what I'm doing. All right? So now it's turned into a multiplication. What do we do with multiplications? What's the first thing we do with a multiplication statement? Jordan?
We multiply.
No, we do something. We look for something else before we multiply. Sadie?
See if any volume can go into anything else.
Yeah, see if we can do any reducing. See if any simplifying. So simplifying. Is there any factors that can divide a top and a bottom number? Do you guys see anything? Yes, Sadie?
3 and
Okay, 3 and 27. What can both of these be divided by? 3. So we cross them out. Remember, a pair, a top on the bottom. So 27 divided by 3 is 9. 3 divided by 3 is 1. Is there anything else that can be reduced here? No, and that's it. So now we go to Jordan's statement and say, okay, now that we simplified as much as we can, we just multiply. So we multiply the tops together. 9 times 2 is 18. And 5 times 1 is 5. And this is not just 18. We also have this negative sign here. So it's negative 18. Okay. Now we're still working inside of this bracket. We just simplified one portion of it. We have ignored this part because that wasn't what we were going to be doing first. That's our second thing. So we can write that in. We still had this here. We were just ignoring it because it was not our first step. Okay. So now we look at this as we go and we've done the division, we have our subtraction here. So when we're subtracting, what things need to be in place before we can subtract? Michaela? Same denominator. Oops. We need to check the denominators, and they are the same. Right? So we can just now combine the numerators. So the denominator stays the same. On the top, we have negative 17 minus negative 18. Right? You can try doing it in your head, or you can go negative 17 minus negative 18. What would it be? Can anybody do this head? It should be pretty straightforward. Sadie? 1. Right? Why we can do it in our head is if you combine these two together, you can say negative 17 plus 18. Right? So that's how you can quickly get to that. So that is inside of these square brackets. So we refine this bracket all the way down to a single fraction. That's the goal. You pick something to work with, you work with it all the way down to a single number or fraction. Okay? Then we look at the other stuff that we ignored. And we ignored this. Right? And we're still need to do that. So that's a part of our expression. So I'm going to just draw a little arrow here. And this is what we forgot to do. Or still haven't done. So now, this is multiplying, because this bracket is multiplied by this. What do we do here? It's another multiplication statement. What's the first thing we check for? Sadie? Yeah, if we can reduce. And can we reduce? No. So now we can simply just multiply the tops and multiply the bottoms. So on the top is 1 times 1 is 1. 5 times 2 is 10. Now, technically, each one of these spots should also have a little equals line, because each line is equal to the one above. So that's just part of your good math writing. Make sure you include that. And I think we'll stop at that point. Right?